ridiculous to think that we could even have an atmosphere if we're in a vacuum, just to start with, let alone hurtling through the vacuum at the ridiculous speeds that you spinning spaceballers believe we're moving.
So there's no problem with having an atmosphere next to a vacuum. We can actually do that here on Earth.
What?
Yep.
Where?
Inside of I think they're fusion reaction chambers. You can get they do it with plasma, but they have an extremely strong electromagnet on the bottom, and it's you can see the plasma circulating on the bottom of the chamber, held down there by the electromagnetic force or whatever, and then above it is a vacuum. So that's fine. But the other thing is, we don't have to go to that. The same reason that you apparently can't have an atmosphere next to a vacuum, because a gas always equalizes in pressure, sure. That also means you can't have pressure gradients. We have pressure gradients. The atmosphere is much thinner up top. We've sent weather balloons up into the sky where the pressure is 1,000 times less than what it is on the surface. So if there is no gravity holding it down, if gases must equalize in pressure, which is a true statement for containers that we study on Earth, because the gravitational, the gradient or whatever we want to call it is negligible inside any regular sized container. So it's a good way to talk about the behavior of gases under typical conditions. Anyways, if your flat Earth ideas are true, the air needs to be flying upward constantly, but it isn't. So,
no, it doesn't. No. The Earth is stationary, where the physical plane at the bottom of the known universe.
No, that's not what we're talking about.
According to
your explanation.
Density.
Listen, your explanation for why an atmosphere cannot exist next to a vacuum means you cannot have a pressure gradient either.
No, that's not true. That's
yes, it
absolutely
is
not
true.
You can have a pressure gradient, as we do in a swimming pool.
No, you can't.
Pool. The deep end of the swimming pool is going to have more pressure at the bottom of it than at the top.
Because of the weight, which is caused by gravity, yeah.
No. Weight is caused by the density of the molecular makeup of a single atomic structure of
density
everything.
Is a
consequence. Gas itself has the density, and therefore you will have a pressure gradient because there's going to be less air above you the higher you get. It's not. It's exactly how it works.
The density.
Why would you call that dumb? I thought you said
Iron Horse.
Iron Horse.
Iron Horse. Why is the atmosphere more dense at sea level than it is 10,000 feet in the air?
Because there's more air above you at sea level than there is at 10,000 feet in the air. Just like in the swimming pool.
That's a tautology. All you did was restate the claim that it's more dense. Why is it more dense?
There's more air. It's not more dense. There's just more of it, which creates a pressure gradient.
That's the definition of density. More matter per unit of volume.
Exactly. It is all density. You've got it now. Yeah. Thank you.
Good. No, you have not answered. You have not answered the question, and we're not doing anything until you admit that you don't know or come up with some sort of explanation. Why is the atmosphere more dense at sea level than at 10,000 feet up, for example?
The air itself is not more dense. Every air molecule has its own density, which is part of its molecular makeup. And when you got more of it...
I'm not talking about molecules. I'm talking about air. Air is a material composed of matter. So quit dancing around it.
Molecules dancing around each other. That's what gas is.
This is so sad. Quit dancing around it. Why is the air more dense at the bottom?
It's not more dense.
Yes, it is.
There's a higher pressure of it because there's more of it pressing down on itself.
That's what density is.
From its own density makeup.
Yeah. Why does it do that?
Because of density.
Density isn't a force. It can't make anything happen.
Of course.
But also, I'm asking, why is it more dense? And you're telling me because density. That's not an explanation.
It is an explanation.
Why do blue things stop? Here's the equivalent of what you're doing. Why do red things look red? Because they are red. That's what you're doing. So I need an explanation. Why is the atmosphere more dense at the bottom? Why are the air molecules more closely crammed together at sea level than very high up?
Do you understand that every molecule of stuff is made up of stuff?
Please
That
answer the
stuff
question.
is what describes its density. How can I not describe what it is without describing what it is? You know, I
Oh,
wouldn't
this
say
is
that the
so
red
dumb.
thing is
The
blue.
the
Would I say a red thing is blue
composition
when I
of
know it's red?
something, iron, the composition of a material is not what its density is.
It
So,
is.
for the billionth time, why is the atmosphere more dense at sea level than high up?
Dude, I've told you
No,
already
you
for the
haven't.
billionth time that it's not more dense. It's
Yes, it is.
exactly the same atmosphere. It's exactly the same. You've just
Yep.
got more
Didn't
of
didn't
it
ask you
above
what
you.
it's didn't ask you what it's made of. I asked you why it's more dense.
Because unicorns.
Okay,
Why wouldn't it be
so
because of what
you
it's made
don't
of, dude?
know, you
Why
don't
wouldn't it
know,
be
you
because of what
don't
it's made
have
of?
anything you can pull on to give an explanation, which is
Are
how we
you
know your model is junk
are you
and
mentally
useless.
deficient, bro? Are you mentally deficient?
Nope.
You were just told everything is made out of what it's made out of, so that has to be the explanation. Otherwise, what else am I going to use?
Yeah, I don't need to even say anything with regard to that. So, let's imagine you and I are in, we're moving on to the next thing. Let's imagine you and I are in a big gymnasium, okay?
Like a warehouse?
A warehouse. That's awesome. I like the warehouse idea. And let's say that we're on opposite sides of it. Well, not even opposite sides. Let's just say we're standing 200 feet apart from each other, okay?
200 feet. Okay.
Let's say that there's a, you know how in the middle, well, you said a warehouse, so whatever. In the middle of the warehouse, somebody hung a giant beach ball, right?
Right.
Now, you and I are looking at the beach ball. If we each took a photograph of that beach ball, would our photographs look identical?
How high is the beach ball?
Let's just say it's 50 feet up in the air, or let's say it's 150 feet in the air. Why not? That's pretty high up.
150 feet? No.
Yep.
No, you would not see exactly the same. You'd see different parts of your beach ball hung 150 feet in the air.
That is correct. What if it was 1,000 feet in the air?
You'd all be looking up at the same base of it, bottom side of it.
But would our pictures be identical?
More or less. They'd appear a bit inverted because you're on opposite sides of the room.
Yeah, but there would be significant parts of the surface area of it that you would be able to see, but I can't see.
I would doubt that at 1,000 feet.
No, 1,000 feet wouldn't create an angle. You and I are 100 feet apart, and it's 1,000 feet up. It's only 10 times
So
higher.
we're 30 meters apart and then it's 300 meters high.
Yeah, it's only 10 times
ridiculous.
higher than it is. It's only 10 times farther away from us this way
Yeah.
than we are that way.
Yeah, I would say you'd barely notice any difference. You might see a couple of millimeters at the most.
Sure, but it would definitely be there. Okay, so here's the problem. On a flat Earth, when we look at the moon, everybody always sees when we take photos of the moon from anywhere on Earth, they're always exactly the same. But on a flat Earth, that's not possible because we would always be looking at significantly different parts of its surface.
That's not true. It's well known that it appears inverted from whichever side of the equator you're looking at it.
Inverted does. I didn't say
inverted.
inverted. I said seeing
see the same
different
phase.
parts of its surface.
We see the exact same phase because we're seeing the exact same projection from the moon being projected down in our atmosphere, which is about 12 to 14 miles high, which is like at least, I think, 70,000 miles high. 70,000 feet, sorry.
70,000 feet? Airplanes fly about half that, which would mean
I
if you
know.
looked at the moon from an airplane, it would look twice as big.
No, because it gets smaller as you get closer to it. That's how the apparition of the
It
holographic...
magically gets smaller the closer you get
Not
to
magically. Not magically. It's just
it.
the way...
Then what's the mechanism?
The moon is a holographic projection projected into our atmosphere. So unless the moon is actually beneath the atmosphere from the height of a plane, you won't even see it.
Holograms get bigger the closer you get to them.
Not when it comes to something in the size of our atmosphere that we're talking about. It has to be within the atmospheric gradient to even be visible. Once you get above that, like if you send a helium balloon up above above that height, you can't see the moon at all. All you see is a tiny little speck of it, and that's the actual moon that creates the holographic projection.
So we'll get to the holographic thing in a second, but regardless of whether or not it's a hologram or a solid object, that doesn't fix the problem that if we're thousands of miles apart looking at it, if the moon is only 70,000 feet up in the air, we can't see the same thing when we take a picture of it. And inverting isn't not seeing the same thing. We're talking about how much of its surface area are we seeing, and we always see the exact same surface area.
Exactly. You're seeing the exact same thing personally projected directly towards you,
which is impossible if this is what's happening.
You're drawing people that are like the size of about 10 Mount Everests. So
that is irrelevant. It's just the only important thing is their position, and you know that.
No.
Quit being Mr. Irrelevant.
About 10,000 times higher than that just to represent 12 to 14 miles high, let alone the actual height of the moon at 70 miles.
70 miles.
That's the trouble with your globers, is you've got no understanding of height.
Buddy.
Perspective.
Buddy, the closer you said I drew the moon too high up when really it's closer. That's worse. Because the closer it is, the more angular difference there is from two observers.
You draw your people too high up. The people are like a little speck. They're not even a pixel high.
You know that's irrelevant, so quit being dumb.
No. It is absolutely relevant because you totally exaggerate the situation to try and prove your point, where you've got no understanding of the real scale of things as they actually occur to human perspective.
Here's the flat Earth. How high up should I draw the moon?
Probably about the height of your pencil. That's the whole problem. You can't.
The height of my pencil?
No, the height of the tip of your pencil.
So tell me when to stop. Tell me when to stop. Tell me when to stop.
If you draw the scale, man,
tell me when to stop.
Do you want to listen? If we're talking about the distance of our horizon,
I am trying to be as generous to you as possible. I'm trying to make this accurate because you complained.
You're just proving your ignorance, man.
Tell me when to stop.
Stop.
Right here? Right there.
Yeah, but you got to draw the person lower than the height of the Earth because you can't do it to scale.
It doesn't. It doesn't matter how big I draw the person. That's just to represent X marks the spot. Here's where they are.
Do you want to hear how perspective works?
No, not from you.
A person 1 millimeter high, you have to have a piece of paper 3 meters long just to represent your distance to the horizon.
This is a model, so this is totally irrelevant, okay?
Why are you using it then? Why would you use an irrelevant model?
To demonstrate that your observations are impossible.
It doesn't represent reality at scale whatsoever. So your imagination is what's impossible.
The only thing that's important are the directions, not the scale for this aspect. So I won't even
draw it to scale. Draw the moon about 20.
Okay, stop interrupting me. I drew the moon where you told me it could work, right here. So I won't even draw a person. I'll just put dots literally on the flat plane itself, little tiny dots. It doesn't matter how big they are because we're just representing their location. Okay? So if that's the moon up there, person A is over here, person B is over there, they're looking at that moon. This is like two people standing on opposite sides of a fence. They can't take a picture and have the picture be identical. This doesn't work. It's impossible. Why are you still muted? You should be able to unmute yourself whenever you want. So you can't these two people cannot take a picture of the moon and have the pictures be identical. They cannot do it.
You refuse to listen to scale. You refuse to listen to scale.
I drew the dot where you wanted me to draw
1 millimeter height of one person looking out at the horizon.
I didn't draw
has to have
people.
A 3 meter length of paper just to get close to scale.
Okay.
So unless you're going to draw the moon about 20 stories high above that piece of paper, you will not even come close to drawing a scale model, drawing the people that far apart.
The paper isn't the Earth. This line is the Earth. So what happened before, you're not engaging honestly because you know you can't explain this. Like when we talked about density, you just talked about composition, as if that proved anything. It
Well,
didn't.
that's what density
And
is.
now you're obsessing over whether the height of the people, which isn't even the significant part of the model. It's just where their location is. So now, unfortunately, we're done with this too because you're conceding that you can't.
You wanted a scale model of the moon to the Earth, not from the moon to the people.
I did that. I asked you, where should I draw the moon, and I drew it where you told me to, and you're still just making crap up. So we're done with this. You can't have. You are not capable of arguing this point.
You're not
honestly
of arguing anything because you can't understand scale whatsoever. If you want it scale to the Earth, that's the height of the moon, but you can't do that to the scale of a person. A person is nothing. A person is less than a cell the size of the big size of the Earth.
I'll explain this one more time. This isn't the original drawing. I placed the people with a height of nothing
is just as ridiculous,
on the plane of the Earth to satisfy Mr. Complainy Pants right here, who said you drew it wrong. So I did everything exactly the way you wanted me to, and you still complained. So we're done with this because you can't have an honest conversation about it. That's unfortunate.
Draw the moon then 20 stories high.
No, because you're a dishonest. You won't be honest about this point, so we can't have a conversation about it.
Earth, and then you wanted to try and invoke people without doing the people scale to the Earth. You're the dishonest one.
Anyways, I addressed that 3 or 4 times, and you still just keep repeating it.
Dismissed it. You just don't want to listen. You're so ignorant, like every other glober I've ever met, because you just don't understand scale whatsoever.
That's not very nice of you. But anyways, you said the moon is a hologram. You said the moon is a holographic projection, right?
Yes. Correct.
A 2-dimensional or 3-dimensional holographic projection?
2-dimensional. It projects as a flat disc towards us from the 3-dimensional actual moon.
Now, we all know that this piece of paper isn't really 2-dimensional, but it's very, very good at representing a 2-dimensional thing. You agree?
Not really, no, because we're talking about light here.
Yeah, 2-dimensional is 2-dimensional.
That's correct.
Okay.
So it appears as a holographic projection towards the viewer.
I haven't made my point yet.
Well, you haven't listened to what the projection means in the first place. So you're trying to second guess what I'm trying to say to try and prove me wrong without even knowing what I'm talking about.
But I'm the one asking you a critical question about this 2-dimensional projection.
Okay, but if you want to know how the projection works, then you have to understand it works in line of sight from the viewer to the moon, so it will always appear flat to every viewer no matter where they are, and it will appear in a different position to every viewer because they're seeing their own personal apparition of it.
Great. So anyways, if it's 2-dimensional, then that means as you change your perspective, it changes its shape. So that's not the reality of what we see. So what's the explanation?
That's what I just explained for you. I just explained that to you. You're seeing your own personal apparition projected to you on the 2-dimensional plane of the upper atmosphere at about 12 to 14 miles high.
How does it look identical to 2 people in 2 different places with different perspectives of it when a 2-dimensional object can't do that?
Because they're all seeing their own personal projection directed to them in line of sight to the actual moon, which is about 60 to 70 miles high.
I'm asking you, how is that possible? You're just saying they see their own personal projection. How are they able to see it identically, even though that wouldn't possibly work?
Have you ever seen like a sunset where the sunset's reflected across the water and it comes towards you, to your feet? And then a person 200 meters down the beach is going to see their own personal projection of the sun coming reflected to their feet. Everybody sees their own personal apparition of light coming to their eyes that they don't see the same one as coming to your eyes. So it's going to appear the same to them as it appears to you, but it's going to be in a different place.
Yeah, this didn't work at all.
Works.
Okay.
So you don't understand personal perspective and the way light works. Light can only be seen through your own eyes. You can't see it through somebody else's eyes.
Interesting. Okay.
No, don't tell me I did another cartoon.
Here's what's going on. We have a flat Earth. We have a flat moon. These people are looking at it from 2 completely different angles in 2 completely different places. but they both see the moon appears as a circle. Now,
Correct.
how is that
Possible.
How is that possible, considering an actual disc, flat disc? If I was looking at it from directly below, it would look like a circle. But if I was looking at it from anywhere else other than directly below it, it would appear as an ellipse, and it would become more and more eccentric in its
And why would it do
ellipsicity.
that? Does the sun start to look like an ellipse as it's setting?
No, because it's a sphere. So, anyways,
Okay. So there we go. So of course it wouldn't.
how does the moon do this? I need an explanation.
So now put the round moon about 3 times higher than the flat apparition they're seeing.
Yeah, it would still
realize,
not be a perfect circle from anywhere other than directly below it.
Everybody is looking at a completely different part of the atmosphere to see their own holographic apparition of the moon.
Yeah. What makes the moon
You can't even stop and think
maintain
about it,
a
can you?
circular shape despite the fact that if you're anywhere other than directly below it, it will skew toward an ellipse?
Because it's coming from a spherical shape. So it's always going to project a spherical shape to your eyes.
So you have now contradicted yourself. I asked you.
Not.
There's no such thing
I
as
have not contradicted myself.
There's no such thing as a two-dimensional sphere.
You haven't listened to a word I've said.
Yes, I have. You said that it's two-dimensional, and then you said sphere. There are no two-dimensional spheres.
The holographic projection that we see is probably two-dimensional because that's what's getting projected to our eyes from the spherical moon. So it's always going to appear a sphere no matter how you look at it.
Yeah, so then it's not two-dimensional, so you contradicted your earlier claim.
But the holographic projection can still be two-dimensional. It's just coming from a
The
three-dimensional
moon can't
object.
be a sphere that is also a two-dimensional hologram.
Yeah, but it's not the moon. The moon we see isn't the moon. It's the projection.
Yeah, great. So,
Holographic plasma projection created in our upper atmosphere by ionizing the particular gases krypton and xenon that create the black and white light that we can see from and read from at night time under a full moon, but we can't see color pictures because it doesn't produce colored light. It just produces a black and white light. That is what the moon actually is. But it comes from the source, which when we're above the atmosphere, we can see it's a tiny little dot. And on occasion, we can sometimes see what we think of as a star through the moon. That is actually the moon itself. That it's the moon we see is not the moon.
You see stars through the moon?
A star, which is the moon.
You see a star through the moon, but that star in and of itself is the moon?
Correct.
What the hell does that even mean?
what evidence that the moon is a star do you have?
Well, it's not a star. It just looks like a star because it's about the same size to our visible eyes.
Okay, interesting. What is it that allows a projection to only be partially illuminated?
Well,
How does that work?
You have to draw the line of sight from each viewer towards the
We don't
moon.
need a line of sight for each viewer. I'm asking you how the projection
do,
does
because
that.
Our perspective works through line of sight. That every person, as I said, with the sun reflecting across the water, it only comes to the person who's looking at it. You can't see somebody else's perspective of sun coming across the water. It's exactly the same with the moon. You have to be looking directly at it, and your personal apparition is going to appear in that layer, which is about the 12 to 14 mile high layer.
So, not my question. My question was, how does the projection produce a moon that only has parts of it illuminated and different parts every single night? How does it go through a cycle?
Oh, so another question. It's just its relative position to the sun. Like if we consider the sun to be like a 24-hour, the hand of a 24-hour clock, for example, so it goes around us once every 24 hours, the moon is very similar to that, except it takes 24 hours, 50 minutes a day.
Cool.
And so as a result of that, a different part of the illuminated side of the moon is going to shine through.
Yeah, but if you were in a different spot, you'd see a different quantity of it.
No, you wouldn't.
illuminated.
No, you wouldn't, because it's
Yes, you would.
It's the position of the sun relative to the moon, or the moon relative to the sun that we see. That's what the projection comes from.
So wait, are you saying there
boy.
is a
This
real
is so
moon, but we
stupid.
don't see it? We just see a projection of it?
Yeah, pretty much. Yeah.
Where the hell is the moon?
Where did you say?
Yeah.
It's about 60 to 70 miles high on the underside of the firmament.
So why do we see a reflection of it and not it? What?
It's not a reflection; it's a projection.
Okay, why
Which
do
I
we see a
guess is a
projection
reflection
of it and not it?
because the reflection gets in the way.
Okay, Iron Horse, got a question for you. Here's my drawing of the flat Earth. Here's the moon, and then this is a top-down view. Here's the moon.
Okay.
Sorry, it's not focusing. Here's the moon, and it's nighttime. Here's the sun, and it's daytime. The light from the sun hitting the moon can only illuminate that part of the moon, right? You're with me so far, right?
Yeah.
Okay. Here's the problem with that. If I were a person,
Yeah, but you got to understand scale, bro. You're not understanding a sense of scale whatsoever.
irrelevant, all that matters are relative positions. So,
Yes, and first-person perspective. That's correct.
So, anyways, that would mean if I were a person here looking at the moon, I would see all this stuff lit up. But if I were over here, I see the dark part of the moon. But the problem
No.
is, the phase of the moon is always the same for every observer every night. So
you've
that's
got no-
impossible.
You've got zero sense of scale there about
The scale
height.
doesn't matter, only the
Scale
relative
is
positions matter.
extremely important because we're talking about the height of it. We're not looking on a 2D little cartoon picture. We're looking up at something projecting from about 60 to 70 miles high, which is about the same height as the sun, projecting down into our atmosphere 12 to 14 miles high, which is 3 to 4 times higher than what, well, at least 3 times higher than what planes normally fly at. It's a massive height, and we're all looking up at the same thing projected into the atmosphere, which the projection comes from the reflected side of the sunlit part of the moon. So that's why we all see a full moon at the same time if we're at night time in that particular example of the picture you just showed.
But Iron,
Great.
there's cities
that
that are farther
didn't
away.
answer anything at all. So let's go to a different thing. A full moon. A full moon. Do you agree that the sun and the moon are on opposite sides of the planet when there's a full moon?
They're on opposite sides opposed to each other, like the 12 and 24 on a 24-hour
So there we
clock.
go. So we can use
Like
this
that.
drawing. We can use this drawing for that too. The problem is, if I'm directly underneath the moon during the full moon, it means I'm going to see this half of it is dark and this half of it is light because my light source is coming from here. You said they're on opposite sides, which means my light source is over here. There's the moon. If I'm under the moon, I will see half of it in darkness and half
Remember
of
that
it
question
in
you
light.
asked me earlier about inside the warehouse, and if we had a spotlight at 1,000 feet high, we'd all see the same bottom side of the spotlight, would we not?
No, you
We're
wouldn't.
talking something 12 to 14 miles high here. We're looking at the exact same
You said
bottom
70
side.
miles earlier. Now you're saying 12
Yeah,
to
the
15.
moon is still that high, but the projection it makes is 12 to 14. I've said that all
God,
along.
this is dumb.
See what I mean? You haven't
Oh
listened
wait,
to a word.
Iron Horse, can I ask something? So there's cities that are farther away from than 70 miles that can be seen if you go up high enough. You go a couple miles just away from that, you see the city from a different perspective. It would seem the city is larger than the moon in your model. Why do we not see the moon from a different perspective when the distance is even larger?
Because we're talking
That
about
doesn't
height
make
perspective.
sense.
We're talking about height perspective. You're talking about distance perspective on the linear scale.
Height
So
Either
is
way,
distance.
the
on the
same thing
linear scale,
applies.
we don't understand about height. Height means it's all above us, all the time.
Yes, but it can't be directly above you at all times. I see the moon at the horizon all the time.
At the horizon.
Yet not directly above me. So I must be getting some type of perspective shift if it's that close. Again, we get a perspective shift on cities that are farther than 60 miles. Why would we not get it with the moon? That doesn't
I
make
don't
any
understand
sense
what
to
you're
say that
talking
it
about.
applies to everything except this one object.
Within a couple of hours, man, the moon is going to be quite high in the sky to your appearance. What do you mean on
But
the
it doesn't. No, because it doesn't change size. If the moon is only
now
70
it's
miles above. Whoa, hey, hold on. If the moon is only 70 miles above the ground, people that are let's say from this point right here, even you agree that somebody several thousand miles away can still see the moon. That means that the moon is literally thousands of miles farther away from this person
That
than the
picture you
people
drew,
directly under it, yet it looks the exact same size.
that
That's
picture you drew a
impossible.
while back, the picture you drew just a little while back where you put the little flat moon and then you drew the bigger moon above it. Can you get that one again?
So many pretty pictures.
I know. 'Cause I want you to do something for me if you don't mind. So
might.
where you've got the flat moon, can you make that flat surface there? Can you make that a line right across the entire sheet, just like the Earth?
That would mean that the moon is the size of the Earth and would take up the entire night sky.
No. I just want you to draw that for me if you don't mind.
No,
Could
because I can already see where that's going, and it
So
doesn't
what you
match
then-
reality,
what
so this
you
is
then do-
unnecessary.
What you then do is you draw an arrow towards the big moon that you drew way above it, and that's where every single individual viewer is going to see their individual projected moon in that same distance away from them in a completely different spot from every other person. That's how it works.
It basically just implies that magic exists, and then suddenly it makes sense.
No, there's nothing magic about it at all. It's exactly how nature works. Everything is, nothing is as it appears. You know, it's even said we see through a glass darkly. Well, that's to do with the firmament itself, which is what the sun appears through and the stars. But the moon, being on this side of the firmament, it creates its own apparition in a completely different firmament, which I call firmament B, which is the atmospheric one at 12 to 14 miles high, where the sky ceases to fluoresce blue once you get above it.
You've got two firmaments. Normal flat earthers are jealous.
Yeah, you got a gaseous firmament, which is the firmament B. So when a high altitude pilot, for example, flies above about 60 to 70,000 feet, he thinks, oh, I've reached the edge of space because the sky no longer fluoresces blue, now it's turned to black. That's about the layer where the moon itself appears when we're looking up through all the atmosphere from the surface. But if we get up that high, all of a sudden now the moon looks like a tiny little star in comparison to the size of the sun. High altitude balloon footage has proved all this, and that's where I've deduced all my observations from and why I have the theories I have. They're not just made up or pulled out of my ass. These are done from real world observations of real world actual things that anybody can test for themselves and check and try and prove me wrong.
Gotcha.
Interesting. Okay, let's talk about sunlight. This
Sure.
drawing. So you agree that exactly half the Earth must be at night and the other half of the Earth in sunlight at any time, right?
Not necessarily.
Okay, then what?
Yeah, that gets even trickier again, because then you have to start drawing the star tetrahedron shape of the skylight through which everything shows, and that would only work for the equinoxes. On the equinoxes,
Sure,
that's
so-
what it looks like.
I believe you're right. This works for the equinox. So very good. Okay. So you agree that if this is where the sun is, then the light from the sun stops at a distance. We don't have to know what that distance is. We just know that it stops at a distance vastly shorter than the distance it covers going in this direction.
Well,
How is that happening?
That's a huge assumption. You don't know that.
Yes, we do know that.
You don't.
Yes, we do know that.
Because 70% of the Earth's surface is actually water. 30%
Yeah.
might be land, and people don't live over all of the land. So for most of the people around the equator, that would be correct. But we don't live on every extremity of that little diagram you just drew.
But Iron, just a second ago, you agreed that at least half the Earth is getting lit up at any given time.
Yeah, during the equinox, that is what happens. So
That's
you need
correct,
to
but-
explain to me, why does the sunlight not go as far in some places versus others?
Several things. It's to do with the height of the sun, it's to do with the attenuation of light, and it's to do with the star tetrahedron skylight through which the light itself appears. So
Go
once
on.
it reaches external to the star tetrahedron side of the intersection point, which is the equator, once it's outside of there, then the light actually gets shaped further and further outwards until basically it's showing 3/4 of the Earth will be in sunlight during the southern summer on the
Not the
December
question. The question is during the equinox, why does the sunlight not go as far in this direction versus that direction? That's the question.
Because the sun is not in a position, it's in an apparent position as it shows through our firmament.
Okay, but
So
why does the
just
light stop?
so magic.
No,
The
light
sun
in
isn't
any way
in
can
a
only go
place,
so far.
it appears to be in a place.
Correct.
Okay, so why does that make its light travel different distances?
Light doesn't travel, so you can forget about that too.
What does that mean?
Well, light doesn't travel. Light is caused by the electrostimulation energy of the sun itself, and that is what ionizes the gases of the atmosphere, which create the light.
Is the sun where I am?
No,
Then how is it that I see the sun?
you are looking up through the firmament and you're seeing a hotspot apparition of it
How am I seeing it?
with your eyes.
And what is it that my eyes do that allow me to see it?
They allow light to enter and allow parts of your brain.
Oh, okay, so
interpret the
light
signal
does
to be
travel
light.
because the light has to enter my eye. So, anyways,
Now, well,
light does
but you can
travel,
look at it
even
like that.
according to you, light does travel. So
You
why
can
does light
imagine
travel
it.
different distances on your flat Earth map?
Okay, consider this scenario. A frozen lake, a fish under the frozen lake looking up through.
Nope, not listening to that. I want a direct answer to why does the light travel different distances? So unmute yourself whenever you want and answer that question.
Yeah, but the tetrahedron fish, bro. Come on.
All right, yeah, I know.
I don't think he knows that he's. Oh, there we go.
Okay, so you got a fish under the ice of a frozen lake. When the fish looks up through the surface of the ice, he sees a hotspot apparition of the sun, but he can only see 10 feet in front of him. Everything else is in darkness. But as he travels through the water, the hotspot apparition moves with him and the light travels with him and he can see further. Does that make sense?
It's not an answer to the question.
It is an answer to the question because the sun moves with the viewer.
So, like, if it's daytime for me, and then I go all the way to the other side of the world instantaneously, the sun will move with me to the nighttime side?
Not if you move it instantaneously, because the sun doesn't
Damn.
cover the whole entire surface of the earth. You know, like you can, it will in the lake.
But
You
I
know,
thought
you
it
can-
followed
If
the
I
observer.
Iron
which is
Horse,
only a mile
if
away
I
or
s-
whatever,
Iron
that will
Horse,
work.
if I stay still, does the sun continue to move across the sky?
Of course it does. It moves like the hour hand of a 24-hour.
Okay, so then your thing about, well, if the fish moves, the sun moves with it, that obviously was completely irrelevant, because whether or not I move, the sun moves.
Yeah, but
So
if
again,
you
my
move,
question
it will
is,
move
why
with
does
you.
the sunlight travel different distances on your, according to the flat Earth belief model, whatever?
Because the relative position of the actual sun coming through the firmament is only going to propagate the light so far due to the atmospheric conditions.
Why? That's not an answer to the question either.
It is, because
Why
it's
does
about
it
the angle.
not go as far as in other places?
Well, it does. It's just that it's not where it appears to be. Just like for the fish, when he's traveling through the lake, the sun moves with him. If you move, the sun moves with you. If you stay still, it obviously moves independently, but it's also doing that whether you move or not. It's
The
going
sun
to
doesn't
still
move
appear-
with you. The sun has
It
its
does.
own motion.
If you had a building standing in front of the sun to you, and then you moved across from in front of the building, you can see the sun again. So it has moved in.
No,
a
I
position
moved. The
to you.
sun has its own motion. So this thing you're saying is just, it's so dumb. It makes absolutely no
There's
sense.
both. There's both. I'm not denying the sun's own motion, but if you move, even though the sun itself is only really, really slowly moving, its apparent position moves according to your point of view. Everything is personal perspective. That's the most important thing of the whole thing.
You're just
Everything is
referring
so
to
wrong, because
parallax,
nobody
dude.
understands personal perspective.
Yeah. So again, yeah. parallax, perspective shift, that doesn't make the light travel different distances, okay? So why does the light travel different distances?
It's not traveling different distances.
Yes,
Yeah,
it is. It has to be.
One part is going to be in twilight of the morning, one part's going to be in twilight of the evening, and midday is going to be directly beneath the sun. But we don't see from the top down. We don't have a God's eye view of the world. We see from personal perspective, looking upwards through the firmament, which is exactly how the fish is looking up through it to see their own personal apparition of the sun in the ice layer. Our firmament is the equivalent of that ice layer, and that is how we are seeing the sun. We're not seeing the sun in its actual position whatsoever.
Okay, you never answered the question, but that's okay. We can go on to the next thing.
I did.
Why is it that the night sky in the southern hemisphere rotates around a central point? How is that possible?
It's an apparition, and once again, we're seeing the celestials themselves appearing to move because of the way the star tetrahedron skylight rotates around above us. So when we're in the north, it's easy to see where Polaris is and see that the stars rotate around that center point. But once we get to the outside quadrant, we're looking through a fractal of the star tetrahedron skylight. So we're seeing an apparition of the stars, which are then obviously going in reverse direction, even though they're still going east to west, because we're facing the different direction. But as that fractal then rotates around to another part above the Earth in a different quadrant, they're going to see a similar looking apparition of light, again, because they're looking up to the star tetrahedron skylight.
Dude, are you okay?
The birds are laughing right now.
The seagulls are going off, yeah.
Oh, seagulls. Interesting. Okay.
Hearted.
So, yeah, I don't feel like that answered my question. Not surprising. So
of course not, because it's a very difficult thing to understand. It took me years to work that out. years and years.
Well, you could have figured out the truth in about 5 minutes. But
It's
anyways,
next level
does
knowledge.
the dome above us rotate? Does the firmament rotate?
I have a strong, suspicious feeling that it does, but not a physical dome.
Okay.
It's what
Are
I
the
call the,
stars
energetic.
rotating? Do they have a motion?
It makes it seem as though they do, and for many years I believe the stars themselves are what's in motion, but I think that the star tetrahedron skylight is what's in motion, and that's what creates the appearance of the stars moving. But they obviously are, because we do have the sidereal time, which gives us how we measure out a year. So yeah, there's quite a bit going on.
Right.
The stars are in motion.
So are those
dome.
stars rotating east to west or west to east or whatever, like all in unison? They don't crisscross applesauce or anything. Are they all doing this?
Yeah, that's
Okay.
what I would think.
How can they be moving east to west and then somebody on the southern hemisphere looking south sees them doing this when their motion is this?
As I said, because we're looking at them through a fractal of the skylight. You know, like if you've seen a jewel,
Fractal of the
diamond cut jewel, when you see through a
God, this
fractal.
is horrible. Do you know what a
It really
fractal
is
is?
a bunch of buzzwords.
Yeah,
What is it?
a fractal is a facet. Actually, that's the word I was looking for. Facet. It's a facet of something like a star tetrahedron skylight.
I don't care
know
anymore.
what a star
Glober, you
tetrahedron
ask him a question.
So why is it a tetrahedron and not a hexadecagon? I think 16 sides is pretty cool, actually, personally.
No, I think it's only 12.
I've talked to
like
Aaron
a
Horse a
diamond cut
bunch.
jewel. You know, the most classic cut of a jewel, like a diamond, has about 12 facets, I believe. So I think
God,
the
I don't
reason
care.
we have that is because it actually is a reflection of nature of what we actually see.
Iron, do you have any, like, actual just, I don't know, measurements of the shape of the Earth instead of just a bunch of buzzwords?
What do you
Like
mean?
data?
Measurements?
Measurements of the curvature, like the rate of curvature. You have to prove there is no rate of curvature. Have you done that?
Yeah, of course.
Okay.
Zero is always going to
Yeah.
be zero. Zero
Yeah.
is zero. So there's no point measuring something that doesn't exist.
Okay, so you didn't even try. Okay,
Yes,
that
yes.
answers
I've
my
I've
question.
observed.
He claimed
Multiple
that
times.
there is no curvature, so therefore there's no need to measure it. This is
That's
really
the-
interesting because I actually just proved that the Earth is not flat because it's not flat. So,
Really? How
anyways,
did you do that?
but despite the
How
fact
did you
that
do
Earth
that?
is not flat, I will ask you one more question about the spherical Earth. What causes a lunar eclipse?
Something comes between the sun and the moon.
What?
Oh, what specifically? To the best
Yeah.
of our knowledge, it's a thing called Lilith in Western cosmology, and in Eastern cosmology, it's called Rahu, and it's basically a dark moon, which is so close to the sun we rarely ever see it, but it comes between the sun and the moon to cause the eclipse.
So that's the stupidest goddamn thing I've ever heard in my life. It's so close to the sun that you can't see it, which is how when the sun and moon are as far away from each other as they ever get during a lunar eclipse, it gets in the way between us and the moon. So it's so close to the sun
have you ever
that it
seen
gets
a moon?
between the sun and the moon when they're at their farthest possible distance.
Could you show me?
You're
a
an
picture of a new
actual
moon?
idiot.
Could you show me a picture of the new moon, please?
No.
Of course you can't, because you can't see the new moon because it's too close to the sun, which renders it invisible. It's exactly the same thing. This thing always stays so close to the sun. It's like a new moon. You can
If
never
it's
see
so
it.
close to
we
the
don't see it.
during a lunar eclipse, the sun and the moon are at their farthest possible distance
Yes,
away from each other.
exactly. That doesn't change.
Yeah, which means
What
the
changes?
thing that's always so close to the sun that you can't see it can't be where the moon is.
It's not where the moon is. It's near the sun. It comes between the sun and the moon, but it still stays the
Oh
same
my
distance.
fucking
from the
god,
sun.
you're an idiot.
You're a moron.
That's another word for idiot. Yeah, congratulations. What you just did there was argue, I know you are, but what? Oh, he left. Okay, well.